Okay. Good morning. Good morning. Good evening. Good afternoon. Depend on where you are watching. Good afternoon. Depend on where you are watching it from. Uh, this morning, we'll be looking at this very question. Is a differential equation, second order differential equation, and I'm going to break it down for you to understand. Most especially those who are in polytechnic, HND, university, 200 to 300 level, and mathematics students. Anywhere you are, differential equation has been a problem to a lot of mathematicians, engineers, most especially with boundary conditions. So we are going to look at it, and I'm going to use two methods, one numerical and D operator method to solve this problem. Please, I want you to like, share, and comment. I'll be very grateful. And if there is any question, ask, drop it in the comment section. I will get back to you. Thank you. Okay, let's go ahead to solve this problem. The question says, find the general solution of 9d square y over dx square minus 24 dy all over dx plus 16y equals to 0, and also the particular solution given the boundary condition that when x equals to 0, y equals to dy over dx equals to 3. Yeah, I'm going to explain a lot of things here. I know the boundary condition here kind of confusing, but I'll break it down for you to know and understand. Is that clear? Okay, so let's ask ourselves this question. How can we find the general solution and the particular solution? It's a very simple question to consider. I'll break it down. Is that clear? Okay. So, if you can see what I am saying right now here, let's write solution. We have here 9d square y all over the x square minus 24 dy all over the x plus 16y equals to 0. Is that clear? First, when you come across second order differential equations of this form with boundary condition, the boundary condition will make you to obtain the particular solution. If boundary conditions are not given, there is no need for particular solution. Take note. Is that clear? The particular solution should be obtained when boundary conditions are given. Take note. Is that clear? But if there are no boundary conditions, there is no need for the particular solution. But given here, we have been given boundary condition. So it means before we can obtain the particular solution, we'll obtain the particular solution using the general solution. So at first, we are going to consider the general solution. Is that clear? Please do me a favor, share, like, and comment. Love you guys. Okay, so let's look at it together. Here, how can we find the general solution of this second order differential equation? You know, one of my videos, I mentioned that when we have a differential equation of this form, we call this differential equation an homogeneous differential equation. Why is it called an homogeneous? Because it is equal to what? 0. But supposing this is equals to exponential x, or x plus exponential x. This second order differential equation should be called non-homogeneous. Is that clear? Take notes. I think one of my videos I try to explain the type and order and the degree. Is that clear? So you should take note. Is that clear? Okay. So if you agree with me, let's look at it together. So what will be the solution to this second order differential equation is you now let y be equals to a exponential mx. The reason why we are using y equals to a exponential mx because there y is the dependent variable, two of us. X is the independent variable. So that is why we are letting y equals to this. But supposing we have here maybe t d squared t all over the theta square. Yeah, we are going to use let t equals to a exponential what? M theta. Take note, it's very important. Is that clear? Okay, so let's proceed. Let us proceed. So now, since this is the solution to this second order differential equation, you agree with me? So what we need to do here is we have to differentiate this function twice. Why? Because this is a second order differential equation. So depending on the notation given, here the notation here is d squared y all over the x squared and dy all over the x. But sometimes you may see the notation in this form, y prime prime and y prime. And sometimes you may see it in this one, y dot dot and y dot. So since it is in this notation, we'll be using this notation. Take note. Is that clear? Okay. So if you agree with me, let us go ahead to differentiate this function. Any question before I proceed? Okay. No question, right? Okay. So let's move further to differentiate this. So it means we are going to have our dy all over the x is equals to am, because if we differentiate this, it's going to give you exponential mx and d squared y all over the x squared is equals to am squared exponential mx. Do you agree with me? So what we need to do, we have to substitute this and this and this into this second order differential equation so that we'll be able to find the general solution. So here is, since d squared y over dx squared is am squared exponential what? Mx. So we write am squared exponential mx. Then what do we have here? Minus 24. Here is dy over dx is am exponential mx. Amen. Then what do we have here? Plus 16y. What is your y? You said let y be equals to a exponential what? Mx. Then equals to 0, right? Do you agree with me? Okay. So if you agree with me, this implies that, look at this equation, what is common? Factor out the common factors. A exponential ms is common, so we factor it out. A exponential mx, open bracket, we are going to have 9m squared then minus 24n, two of us, then plus 16 equals to 0. Can you see now? Look at the board very well. Look at the board very well. Can you see now? Because if we factor out this a exponential mx, 9m squared will remain here. Then here, factor out a exponential mx minus 24m will be here. Look at it here. Then factor out exponential a mx 16 will be here. 2 of us then equals to 0. 2 of us. Any question? Please look at the board very well and ask your question. I'll be very glad to respond to you. Okay. So, if you agree with me, let us proceed further to look at it together. So it means if a exponential mx not equals to 0, then what is inside the bracket will be equals to 0. 9m squared minus 24m plus 16 equals to what? 0. So this equation, this is called the auxiliary equation. Auxiliary equation. Amen. Okay. Auxiliary equation. So now, at this point, this equation, it is called the auxiliary equation. Yeah, you may ask, why is it called an auxiliary equation? You all know that when we have equations of this form, it is known as what? A quadratic equation, two of us. But the reason why we cannot call it a quadratic equation, this equation was extracted from this differential equation. So take note. So that is why it is called what? An auxiliary equation. Is that clear? But ordinarily, it is known as what? A quadratic equation. Take note. Is that clear? So now, at this point, it means we are going to find the roots using this auxiliary equation. You know, in quadratic equation, we use quadratic equation to find, when we have equations of this form, ax squared plus bx plus c equals to 0, it means the roots will now be x1 and what? x2. So the same thing applicable here. The roots will be what? Since we are using m, will be m1 and m2. Do you agree with me? Any question? Please drop it in the comment section if you have any question. Okay, no question, so it means we can proceed, right? Let us proceed. Let's proceed. Yeah, let's proceed. Okay. So if you can see what I am saying here, all these ones we are doing, we are looking for the general solution. It is from the general solution that we can find our particular solution using the boundary conditions. Is that clear? So let's look at it together. Look at it. So now, how can we find this auxiliary equation to obtain our M1 and M2? Look at the board and somebody should tell me. Okay, so it means we can use either formula method or any method as long as quadratic equation is concerned, either completing the square method or factorization method. But for the sake of time, I will advise you to use formula or any other method. Is that clear? So far, so good. Uh, I will just be brief here, since you I will be brief here. I will just write the answer, then we move further to this thing. But I will advise you, at your convenience, use almighty formula to evaluate the value of M1 and M2. Is that clear? So if you can see what I am saying, this equation will give us M 3M minus 4, all in bracket 3M plus 4, which is equals to 0. That is what this equation will give us. How? If you are doubting, let's multiply 3M times 3M. We have 9M squared. 3M times plus 4. We are going to have plus 12M. Then minus 3M and minus 4 times 3M. We are going to have, okay? No. Here is, yeah, this is how it's supposed to be. Yeah. So minus this times this. So here is minus 12M. Then minus 4 times minus 4 plus 16 equals to 0. So as you can see now, we are going to have 9M squared minus 24M plus 16 equals to 0. Can you see now? So it means here, this is what we are going to write here. Our 3M minus 4M, all in brackets, open brackets, 3M minus 4M is equals to what? 0, right? So, you know, in quadratic equation, when you have, we know that AB equals to 0 means A is equals to 0 or B is equals to 0. These two brackets, this is A, this is B. So this implies that we can equate 3M minus 4 equals to 0, then 3M minus 4 equals to 0. This implies that our M1 is equals to 4 all over 3, or M2 is equals to what? Is equals to what? The same 4 all over 3. Yeah. True or false? Look at the board very well. It's true when you look at it, isn't it? Do you agree with me? It is true, right? Yeah, it is true. So if you can see what I am saying here, if you can see what I am saying here, so you can now see that the roots are the same real root, true or false? Because here now our M1 is equals to what? M2, which is equals to 4 all over 3. So when you have the same real root, it means the general solution will now be in this form. General solution is equals to C1 exponential M1x plus C2 x exponential M2x. Because of the reason why x here is because of M1 is equals to M2. That is why x is added here, because they have the same answer, 4 all over 3, 4 all over 3. Do you agree with me? Any question, please drop it in the comment section. Please, I want you to like, comment, and share. Is that clear? Yeah, JMPC, good morning. Oh, why the first why this why? In fact, this is the solution to this second order differential equation. For you to obtain the solution to this, you must let y equals to a exponential mx. It means this is the solution to this second order differential equation. Is that clear? I know you came late, and I mentioned it in my video before we started that the reason why we say y, let y equals to a exponential mx is because in the second order, in the differential equation, y is the dependent variable, two of us. Then x is the independent variable. That is why we now say, since y is the dependent variable, y is equals to a exponential mx. But supposing the differential equation is of this form, 9 all over the theta, then minus 24 d dt all over the theta, then plus 16 t equals to 0. It means we are not going to say let y. The solution to this problem, because the independent variable here is theta, then the dependent variable here is t. So the solution to this second order, second order differential equation will now say let t be equals to a exponential m theta. Do you agree with me? So this is the solution to this differential equation. So anytime you come across differential equations of this form, always bear it in mind that one, you must consider the dependent variable and the independent variable. Take note. Do you agree with me? And where are you watching from? Do you agree with me? JMPC. I'm not a prof, I'm just an ordinary BSc holder. Oh, from Chad. Thanks for watching. Please, I want you to like and share, comment. I'll be very grateful. Invite your friends to be part of the class. Is that clear? Okay, so let's proceed. Is that clear? Let us proceed. Let us proceed. Okay, as I was saying here, so you can now see that the roots, they are equal, the same. So the general solution will now be in this form. So this implies that our y of g is equals to c1 exponential m1 is the same thing as what? 4 all over 3x, then plus c2 x, the same answer, exponential m2 is the same thing as what? 4 all over 3x. So this is the general solution to this second order differential equation. But we are not going to stop here, because the question says also find what? The particular solution given the boundary condition. These are the boundary conditions. The boundary conditions that when x equals to 0, y equals to dy all over the x equals to what? 3. Yeah, I know very well that if you are not a mathematician, this condition here may get you confused. Is that clear? But I'm going to break it down for you. So this here, this implies that when you see, so for us to obtain the particular solution, we have to introduce our boundary conditions into the general solution. But let's take off this G. Is that clear? So we now consider boundary conditions. Boundary conditions. Is that clear? So the boundary conditions are x is equals to 0. Then here it says y equals to dy all over the x, which is equals to 3, right? So it means y is also equals to 3 and dy all over the x is also equals to 3. That is the meaning of y equals to dy all over the x equals to what? 3. Do you agree with me? Any question, please drop it in the comment section. Do you have any question? No question? Can we proceed? JMPC. Can we proceed? Hope you are following. Do you have any question? No question? So it means we can proceed, right? It's okay. Let us proceed. So as it is now, from here, we can find our C1 looking at this general solution with this boundary condition. So what we need to do here is when x equals to 0, it means y is equals to what? 3. True or false? It's true. So from this general solution, we are going to substitute in y. So in order for us to obtain either C1 or C2. So here, y C1, okay, let me write it here. 3 equals to C1 exponential 4 open bracket all over 3, then times our x is what? 0, right? What do you have here? Plus C2, then x is 0, right? Times 0 exponential 4 open bracket, all in brackets 0. Can you see now? So you don't need a prophet to tell you. All of this will be 0, true or false, because of this 0. Then here, 0 times 4 over 3 is, we are going to have, look at it, we are going to have 3 equals to C1 exponential raised to power what? 0. You know, anything raised to power 0 means what? 1. True or false? So this implies that our C1 will now be equals to what? 3. Is that clear? Then now, the reason why we are doing all this is for us to obtain the particular solution. The particular solution, how are you going to know that this is a particular solution? It means we are to find this unknown, C1 and C2. Then after finding C1 and C2, we substitute it back to the general solution. That is your particular solution. Do you agree with me? Are you following? So now here we are able to obtain our C1. So what left is for us to obtain our C2. We have to differentiate this general solution once. Look at it. Then substitute 3. Okay, so when we differentiate this with respect to, can I clean this part so that we can make use of yeah. Okay. Okay. Yeah. Do you agree with me? Any question? No question? Okay. So we can proceed, right? So let's differentiate this general solution. Then we are going to have dy all over the x is equals to, we differentiate this exponential 4 over 3x, we are going to have 4 all over 3 c1 exponential 4 all over 3x. Then here we have plus, here we have two functions, two of us. We have x and exponential 4 over 3x. So it means we are going to introduce product rule, two of us, to differentiate this function. So either you hold this c2x constant, differentiate this one, use it to multiply c2x constant, then plus you hold c2 exponential 4 all over 3x, then differentiate x and use it to what? Multiply. So if we hold this constant, it means if we differentiate, we are going to have 4 all over 3 c2x exponential 4 all over what? 3, then plus differentiate x, then hold this one constant. If you differentiate x, you are going to have 1, use it to multiply c2 exponential is the same thing, 4 all over 3x. Do you have any question before I proceed further? Any question? Amen. Any question? No question? Do you have any question? Oh, no question. Okay. So let's proceed. Let us proceed. If there is no question, let's proceed. Is that clear? So it means we have to introduce, recall that x is equals to 0, then dy all over the x is equals to 3. So let's substitute in here. So here will be 3 equals to 4 all over 3 c1 exponential x is 0, place of all in bracket 0, then plus 4 all over 3 c2, here will be what? 0. True of false? Because of this x is 0, then plus c2 exponential 4 all over 3 open bracket 0. True or false? Here, mind you, here is okay, let me break it down. Is that clear? There will be 3 equals to 4 all over 3 c1 exponential 4 all over 3 times 0 is 0. Then all of this is 0. Then plus here, this place here will be what? This times 0 is 0. True or false? So can you see now this is 0, but C1 is equals to what? 3, isn't it? So it means our 3 equals to 4 all over 3 times C1 is 3. This is 1 plus this is C2. So this cancels this. So it means our C2 will now be equals to 3 minus what? 4. Which is C2 is equals to minus 1. Can you see now? But mind you, our general solution was given as y equals to C1 exponential 4 all over 3x plus C2 x exponential 4 all over 3x, two of us. So now I told you that we obtain our particular solution using the general solution as long as boundary conditions are given. So we make use of the boundary conditions to obtain our particular solution, which you know that we have to find the unknown, which is C1 and C2. So you can now see that our C1 is 3, then our C2 is what? -1. So the particular solution will now be for us to substitute in this unknown. So that is your particular solution. Is that clear? So therefore, our particular solution YP. This subscript P means particular solution. Subscript G means general solution. Take note, should in case you see things like this in any textbook, as long as differential equation is concerned. So here will now be, what is our C1? C1 is 3. So instead of this, we are going to write 3 exponential 4 all over 3x plus, but C2 is equals to -1. So minus times plus. So here will be what? Minus. So minus, what do we have here? X exponential what? So here is x exponential 4 all over 3x. Do you agree with me? So this is the general solution and this is the particular solution. Any questions so far? Any question? No question? You don't have any question? No question. If you have any question, please ask. Ask any question. No question? If there is no question, let's move further to consider more example. Is that clear? Let us move further to consider more example. Okay. Okay. Yeah, let's consider some applications. Yeah, we have given the differential equation, given the differential equation, d square v all over the t square equals to omega square v. Amen. Where omega is a constant, show that show that its solution its solution may be expressed as V equals to 7 cos omega t plus 3 sin omega t, given the boundary condition, okay, boundary conditions that when t equals to 0, v equals to 7, and our dv all over dt is equals to 3 omega. Yeah, is a very interesting question. So we'll look at this question. Yeah, we'll look at this question together. Let's look at this question together. Okay. As simple as ABC, what we need to do is the same approach. Is that clear? We approach this question the same way we did our first example. Right now, let's write solution. So what we need to consider is look at the differential equation. D square V all over dt square is equals to omega square V. Yeah, I know. Let us just assume that this is the first time you are saying something like this and you don't know anything mathematics. When you come across something like this, because of this square and this is equals to this is a differential equation, second order differential equation. Is that clear? What we need to do is we have to bring this one to the left hand side. It means this implies that this is the same thing as dv all over the t square, this d square dv, d square v all over the t square minus omega square v equals to 0. So now this is a what? Second order homogeneous equation. Can you see now? So what are we going to do now? Recall, I mentioned something. So what will be the solution to this second order differential equation? Can you tell me? Somebody should tell us what will be the solution. You know, the other one I said let y equals to a exponential what? Mx. Two of us. And this was the solution to that our previous example. So as it is now, what will be the solution to this? Somebody should tell us. Okay, so in order not to waste our time, the solution to this differential equation will now be, since the dependent variable is v and the independent variable is t, we are going to say let v be equals to a exponential mt. Can you see now? So here we don't have the first derivative, but we have the second derivative. So the most important thing is we just need the second derivative. So what we need to do, we have to differentiate this function. How many times? Twice. So our dv all over dt is equals to am exponential mt, and this d square v all over the t square is equals to am square exponential mt, right? Do you agree with me? Okay. So if you agree with me, what we need is this d square v all over the t square, because we cannot find the first derivative here. So we are going to substitute this here and these two. That is what we need here, because we have v here, two of us. So here, instead of this, we write a m square exponential mt minus omega square. Our v is a exponential mt equals to what? 0. So now look at the board very well. Look at the board. You can now see that something is common. What is common? Look at the board and tell me. What is common here is a exponential mt is common, two of us. So what we need to do here, factor it out. So a exponential mt, open brackets, m square minus omega square equals to what? 0. Can you see now? I know you may ask, why are we having m square and minus omega square? Look at this. I asked us to identify the common factors here. Then we factor it out. This is am square exponential mt. So a exponential mt here. We also have a exponential mt here, two of us. So we can factor it out. Amen? We can factor it out. Then we left with m square here, minus, we'll be left with minus omega square, two of us. Any question? Do you have any question? Yes or no? No question, right? Okay. So if this not equals to, if a exponential mt not equals to 0, it means this will be equals to 0. M square minus omega square is equals to 0. So now this is our auxiliary equation. This is our auxiliary equation. This is the auxiliary equation. Amen. Auxiliary equation. Do you agree with me? Okay. You agree with me? This is the auxiliary equation. So it's easier for us to obtain our M1 and M2. So now what we need to do here is what we need to do here is this our m square is equals to what? Plus omega square, right? Do you agree with me? Plus omega square. So what we need to do here is we have to square both sides. It means our m now be plus or minus, right? Square root of omega square. Two of us, look at the board. True or false? Do you agree with me? Okay, this is square. Okay, so if you agree with me, it means our m now be equals to, when we have assuming square root of a squared, this is the same thing as a squared all in bracket raised to the power of 1 all over. So by the time you apply power law, so here will now be what? A raised to the power of 2 times 1 all over 2. This and this will cancel. Going to give us a. So the same thing will happen here. So here will now be plus or minus omega. Is that clear? Plus or minus omega. So you can now see that our because of this plus or minus means plus comma what minus. So it means we are going to have our m1 equals to omega and m2 equals to minus omega. Do you agree with me? Okay, so if you agree with me, it means our general solution will now be c1 exponential m1x plus c2 exponential m2x, true or false? So here will now be y is equals to c1 exponential what? m1 is omega x. Oh, sorry, we are dealing with t, not x. Please take note, is very important. So here is supposed to be t, that is the independent variable t. So here is t, amen. Then plus c2 exponential minus omega t. Now you see now, you agree with me? Any question up to this point? Please ask your question. Do you have any question? Any question there? Oh, I think there's a mistake there. We are not talking about y. Here supposed to be v. The dependent variable is v. So here supposed to be v. Please take note, it's very important. Is that clear? Okay. So if you agree with me, so it means what we need to do here is we have to consider this, and this. Is that clear? They said, because they said maybe show that its solution may be what? Expressed as v equals to 7 cos omega t plus 3 sine omega t. So look at the board very well. Is that clear? So what we need to do here is we have to substitute in boundary conditions. So where it said boundary condition, we have t equals to 0, v equals to 0, and the v all over the t is equals to 3 omega. Is that clear? So our v is 7 equals to c1 exponential omega, this is 0, right? T is 0, then plus c2 exponential minus omega 0, our t is 0, right? That is the boundary condition. Okay, let me just write it out first at the boundary conditions. Given the boundary conditions, we have t equals to 0 and v equals to 7. So using the general solution here, so the general solution here, v is what? 7. 7 equals to c1 exponential omega 0, because our t is 0, then plus c2 exponential minus omega 0, t is 0. Can you see now? Do you agree with me? Okay. So if you agree with me, it means here will be 1. Our 7 is equals to c1, because this is how it will be, plus c2 exponential 0. So this implies that our c1 plus c2 is equals to 7. We can name this one equation 1. Can you see now? Then let us go ahead to, because we are here to find the value of c1 and c2. So let's go ahead to differentiate this so that we can substitute in the boundary condition here. So if we differentiate this general solution with respect to t, we are going to have our dv all over dt now be equals to c1 omega exponential omega t, then plus, here we are going to have minus, so minus c2 omega exponential minus omega t. Then at the boundary condition, we introduce the boundary condition here. Boundary condition where we have t equals to 0. Then our dv all over the t is equals to 3 omega. True or false? True or false? Look at the board. True or false? It's true, right? Okay. So if you agree with me, look at it here. So can I clean here? Okay, let me just clean here so that we can go ahead to solve. Okay, yeah. It's simple as ABC. It's not difficult. So what we need to do here is let us substitute this. Instead of the v all over the t, we write 3 omega. Instead of t, we write 0, right? So here will now be 3 omega equals to c1 omega exponential omega 0, then minus c2 omega exponential minus omega 0, because your t is 0. So if you can see what I am saying, it means we are going to have omega, okay, let's write it this way, 3 omega equals to omega c1 exponential 0 minus omega c2 exponential 0. True or false? Then here will now be omega 3 omega equals to omega c1 minus omega c2. So this is common, we can factor it out. 3 equals to, or let's just write it this way, omega open bracket c1 minus c2 equals to 3 omega, right? So when we divide through by omega, we are going to have c1 minus c2 equals to 3 omega all over omega. This and this will cancel. So it means our C1 minus C2 is equals to 3. So this is equation 2. So for us to obtain our either C1 or C2, let us use this is a simultaneous equation. Let us solve equation 1 and 2 simultaneously. Is that clear? So if we can solve equation 1 and 2 simultaneously, it means we can obtain one of the unknown, either C1 or C2, two of us. So let us, our C1, we call equation 1 plus C2 is equals to 7, right? So far so good. As you can see now, using what? Elimination method, right? So if we apply elimination method, this and this will cancel, two of us. Yeah. So it means here is 2C equals to this plus this. This plus this is 10, right? C1, 2C1, two of us. So when you divide 2 by 2, you are going to have 10 all over 2, sorry. This is equals to 5. So our C1 is equals to 5. Then from this C1 equals to 5, we can obtain our C2 from equation what? From equation 1. So this implies that from equation 1, by the time we substitute in 5 here, we are going to, from equation 1, if we substitute in C equals to 5 here, it means we are going to have 5 plus C2 equals to 7. Then C2 will now be 7 minus 5, which is equals to what? 2, right? Equals to 2. Am I right? Okay, equals to 2, right? So C2 is equals to 2. So let's come back to our V. I think there is a mistake here. Yeah. Here supposed to be 5, not yeah. Yes, here supposed to be 5 and here supposed to be 2. Yeah, please take notes. Make your corrections. Here supposed to be here. So let's come back to our general solution. That is our what? Our particular solution will now be, we are repeating the same thing, what we did in our first example. So take notes. So now our particular solution will now be, this is V particular is equals to C1 is what? 5, right? So 5 exponential omega t, then plus C2 is 2 exponential minus omega t. So now they said we should express it in this form. It's simple as ABC. We now go back to hyperbolic functions. So note that from hyperbolic functions, when we have exponential t and exponential minus t, yeah, it means it's going to give us cos this and plus sine this thing. So this is where we are going to stop. The network is breaking, it's disturbing. So I'm going to stop here. Thank you for watching. Please don't forget to share, like, and comment. I'll be very grateful. See you again. Bye. Love you guys. Bye.